I'm Adam Briggs, and I'm with Ambri Inc. Ambri is bringing forward liquid metal batteries for stationary large-scale energy storage systems and data centers. This technology is a 4-hour to 24-hour duration system, and it has a lower cost versus lithium-ion for these applications. It also has a 20-year lifespan with minimal degradation over that period. It has strong safety features in that the chemistry does not generate any gas. There's no thermal runaway. There are no flammable materials inside these containers. And the materials are unique. It's a calcium antimony chemistry. So therefore, we're not competing with EVs or other high volume applications for those materials. It's a US invented technology, mainly at MIT and at Ambri, which is based outside of Boston. And we do plan to manufacture these cells and containers in our initial US manufacturing facility. Cells are packaged into trays. Trays are packaged into containers. The containers are about 1 megawatt hour each, 250 kilowatts of power capability. It's a high temperature chemistry, which means it does not require air conditioning systems. It's very suitable for hot temperature locations or very cold temperature locations. Ambri really sharing this technology in order to get on the radar with DOE. We have developed this technology in the United States. We're planning to manufacture it here in the US. We're opening our first manufacturing facility later this year in Massachusetts. And then in the end of 2022, we'll be securing a site for a high volume manufacturing facility somewhere else in the United States. We'd like to work with DOE on setting up those manufacturing facilities and understanding that there are non-lithium technologies coming that will be suitable for helping the proliferation of renewable energy onto the US grid. Thanks for your time.
Pure Lithium is commercializing a breakthrough lithium metal battery technology and manufacturing process that is clean, sustainable, scalable, and cost-effective. Lithium metal is widely acknowledged as the material needed for superior next-generation batteries that are safer and higher energy density. Pure Lithium's novel technology eliminates more than 80% of the current manufacturing costs in lithium metal production, which in turn unlocks widespread adoption of lithium metal batteries that cost less than $50 per kilowatt hour. The United States is home to a diverse range of lithium-bearing deposits, from hard rock spodumene and oil field brines in the southeast to clays, conventional brines, and geothermal brines in the west. Pure Lithium's technology can take that lithium from the ground and put it into a battery right here in the US, leapfrogging the current Asia-dominated supply chain. Pure Lithium's metal electrodes are elementally pure. Our one-step electrodeposition process creates a clean, native interface that's protected from air and moisture, which improves performance and reduces costs. As a woman-owned business, Pure Lithium has embedded working for environmental justice and treating communities as stakeholders into the very fiber of our company. We are uniquely capable of training technicians with high school or technical backgrounds to hold valuable jobs in the battery industry. Pure Lithium's process can be deployed either close to lithium production or in manufacturing hubs. We are an integral part of securing the energy supply chain, and that depends on building the lithium batteries of the future here in the United States.
Hi, my name is Maciej Jastrzębski, and I'm the CEO and co-founder of Align Metal.
And my name is Dean Frankel. I'm the Chief Commercial Officer at Align Metal.
So at Align Metal, we're focused on developing and commercializing technologies for next generation batteries. We're working on technologies both for lithium anode, metallic lithium anode battery components, and the lithium metal that's required to produce them. Ultimately, once commercialized, these technologies will enable cheaper, safer, and more environmentally friendly electric vehicles.
The first technology that we're developing is a lithium metal anode. We make these lithium metal anodes in our Rochester pilot facility that allows us to be both cheaper and better performing than the existing top-down manufacturing process that consists of extrusion and then rolling. Why are we cheaper and better? Because we start with basically zero and build up. So we are a bottom-up process. We use physical vapor deposition to put the lithium down onto a moving substrate in a roll-to-roll manufacturing environment. And we are planning on scaling this production technology to a commercial demonstration facility in 2023 in the US. We believe that that facility and this technology is not only applicable for metallic lithium anodes for next generation batteries and e-mobility, but also in silicon dominant anodes where pre-lithiation is required.
Our second technology allows us to produce metallic lithium from lithium carbonate. Now, lithium carbonate is already widely used in the lithium-ion battery industry. And by using lithium carbonate, and unlike the incumbent process, we are able to eliminate chlorine gas emissions from the metal production process. This is both more environmentally sound and ultimately requires less equipment, allowing us to produce the metal at a lower capital intensity and at a lower operating cost.
When you combine these two technologies together, Li-Metal offers a cheaper, better, and cleaner solution for both lithium metal and metallic lithium anodes. These are industries as an example, with the removal of lithium chloride from metal to lithium carbonate, we believe that there is an environmental advantage and ultimately a permitting advantage for the metal production technology. Moving on to the lithium metal anode, we believe that there's a significant amount of workforce development in areas like roll-to-roll processing. For example, in Rochester, New York, where Kodak has largely shut down operations, there is a tremendous amount of films and roll-to-roll processing experience, and we hope to build on that with these two commercial demonstrations. We thank you for your time and look forward to the opportunity.
Hello, I'm Michael Canada, the Chief Manufacturing Officer at Sion Power. Sion Power, building the future of batteries now. Sion Power is an advanced lithium metal anode technology company with world-class facilities and capabilities. Headquartered in Tucson, Arizona, we currently occupy 2 facilities with full-scale battery research and development and manufacturing capabilities consisting of state-of-the-art cathode coating manufacturing, proprietary protective lithium metal anode manufacturing, and large format metallic lithium cell manufacturing located in our 100,000 square foot facility. Our world-class test facility is equipped with over 2,000 channels for cell testing and formation, as well as a suite of industry standard battery testing capabilities. Today, Sion currently holds more than 470 international patents and patent applications. Launching our next generation Lithium battery technology, we are engaging in development activities with commercial partners and are finalizing our manufacturing expansion plans for the future. We've distilled our expansion initiatives into 3 phases. Phase 1, in an effort to meet current demand, we will launch our new pilot facility that will be co-located on our campus, delivering large format commercial cells of 50 to 75 amp hours. Phase 2, we will expand our manufacturing footprint, entering the Gigafactory class to meet forecasted demand. And as we anticipate continued growth in the EV space and continued market pull for advanced battery technologies, we expect to continue manufacturing expansion efforts to align and meet future demands as our Phase 3 activity. Some of the challenges U.S. battery manufacturers face are common to other industries today, with the first challenge being critical supply chain constraints. This would include availability and sourcing of raw materials, as well as critical component and material availability with equipment vendors. Second, the availability of existing or idle lithium-ion manufacturing facilities that could be retrofit and upgraded with next-generation technology is limited. And third, the capital requirements needed to build and commission battery manufacturing facilities is substantial. Having access to capital and continuity of supply will be vital. Building the bridge for the next generation workforce is essential. As we've entered this new era of electrification and advanced manufacturing, we must focus on the training, development, and recruitment for a variety of disciplines and skill sets. It is imperative that we consider the entire ecosystem, securing public-private partnerships, working hand in hand with educational institutions to build training programs to develop the next workforce is essential. The electrification movement is no longer a question of if or when. The electrification movement is now. Thank you for your time and learning more about Sion Power.
II-VI Incorporated, a Pennsylvania-headquartered leader in engineered materials for more than 50 years, is bringing to market breakthrough technologies to enable the sustainable and cost-effective electrification of the U.S. economy. These include advanced battery materials, proprietary lithium-sulfur batteries, and high-efficiency hydrometallurgical recycling of battery waste. Inspired by work led by Khalil Amin at Argonne National Lab, the engineered material behind II-VI's breakthrough lithium-sulfur batteries is a patented electrophilic carbon skeleton, which chemically binds to sulfur to prevent shuttling loss of the active material. Solving this shuttling issue enables the highest reported energy and cycling performance for lithium-sulfur battery cells. Based on abundant sulfur, these cells contain no cobalt or nickel and can be further optimized for high power performance by adding highly conductive selenium to the carbon-sulfur cathode. To ensure a competitive and stable supply chain for this breakthrough chemistry, II-VI has invested in pilot-scale manufacturing of lithium-sulfur battery materials, electrolytes, and electrodes, and will make these available to cell manufacturers at commercial scale. Completing the whole life cycle approach, II-VI is also at the forefront of hydrometallurgical recycling of battery materials, with processes proven to extract more than 90% of the critical metals value in battery waste streams. This can be applied both to recovery of value from manufacturing scrap and end-of-life batteries. With these initiatives, II-VI is positioned to accelerate electrification of the U.S. economy, enabling next-generation battery chemistries, efficient recycling, and a stable battery material supply chain. Lithium-sulfur cells are expected to enter pilot production in 2024, with battery components and materials available beginning 2023, while pilot-scale recycling will begin in 2025. Challenges to making these activities competitive globally are the need for skilled electrochemical and hydrometallurgical manufacturing personnel, simplified transportation logistics for batteries and battery materials, and support from local, state, and federal governments for the large capital investments required to operate at efficient scale. II-VI Incorporated, whole battery life cycle solutions, enabled by materials that matter.
Hi, I'm Jim Cushing, General Manager of Energy Storage Solutions at Applied Materials. It's my pleasure to speak with you today about how the government and industry can work together to establish global leadership in lithium-ion battery manufacturing. Doing so can create millions of jobs and economic activity. Additionally, through advances in battery technology, we can help fight climate change and drive environmental justice by accelerating the adoption of energy storage in two of the largest greenhouse gas emission industries, power generation and transportation. Applied Materials is the largest supplier of high-volume manufacturing equipment for leading innovation industries such as semiconductor and display. We're leveraging some of those innovations to develop advanced lithium-ion battery technology and then scale it to gigawatt-level production. When we look at where the U.S. is in this industry, we have great potential. We have the world's best universities, the strongest national labs, the leading EV company, and tremendous pipeline of startups, many of them very well funded. but we are losing the battle when it comes to manufacturing and the economic leverage that comes with the surrounding supply chain. So how can we take advantage of our innovation strengths to gain global leadership? In the 80s, the US formed a consortium for the semiconductor industry called Semitech. The consortium created a technology-driven roadmap, which is still followed today. It brought the supply chain together to rapidly develop and release new, better technology. We recommend doing something similar today. Step 1, bring together the consortium. This is a pre-competitive partnership between industry, national labs, DoD, and the universities to establish a technology and cost-driven roadmap. Second, we need to create a physical space for the supply chain to work together with the specific aim of accelerating the development and manufacturing implementation of this advanced technology. Third, and this is going one step beyond where Semitech took it, we need to establish a gigawatt-scale pilot manufacturing facility to prove out both the technical performance and long-term cost potential of these innovations. Last, once we've proven the advanced technology and the cost viability, we can then build gigawatt-scale factories in targeted regions across the US and even globally. Thank you very much for your time today.
Hello, my name is Chad Schaefer, and I'm the director of our digital enterprise team at Siemens Digital Industry Software. I also sit on the board of NADBAT, which is the National Alliance for Advanced Transportation Batteries, a trade association focused on the development and commercialization of advanced battery technologies in North America. Siemens USA has been a national asset moving America forward for more than 160 years, investing $40 billion in the United States over the past 2 decades, and represented by 40,000 US employees. Siemens supports critical infrastructure and vital industries as a technology partner that forms the backbone of America's economy. This includes supporting the battery industry through electrification, automation, and digitalization. Digitalization in particular provides a platform to simulate through the use of digital twin techniques. This is an opportunity to practice and test new ideas virtually versus trial and error in the real world. This can save considerable time and resources. We also have had the opportunity to engage with U.S. national labs and U.S. manufacturing institutes such as MXD in Chicago and LIFT in Detroit. These environments play a role in accelerating innovation. Siemens is actively working with companies along the battery supply chain, from upstream providers of material to machine builders, battery manufacturers, those that consume batteries, and ultimately the importance of recycling. The entire value chain ecosystem matters when it comes to battery. Siemens is also building out U.S. electric vehicle charging infrastructure of the future. We are currently committed to building 1 million EV chargers for the U.S. market by 2025. So when it comes to expanding U.S. capabilities in advanced battery manufacturing, from my perspective, there are 2 main areas of focus. First, we must support domestic machine builders that make battery producing equipment. Helping those that make the machines themselves, which produce both lithium and solid-state batteries, localizes our ability to produce. Today, there is a long wait for companies outside of the U.S. to deliver battery-making equipment. There is also the opportunity to innovate with machines that increase yield and reduce scrap. Second, it's crucial that domestic battery startups can compete at scale. However, a gigafactory is capital intensive. We can support innovative battery companies emerging to create healthy competition. We see that cutting-edge digitalization techniques combined with agility can improve domestic supply of batteries. This will help ensure that America has its own domestic source of battery creation. Finally, I would like to thank you for the opportunity to offer my perspective. The advanced battery industry can be the backbone of a clean and resilient energy future in America. I would be happy to address any further questions in the future. Thank you so much for your time.
Hello, my name is Brandon Babe, Senior Director of Saueressig Energy Business. This presentation addresses the topic area for demonstration of domestic battery cell and component manufacturing, including next-gen chemistries and novel manufacturing processes. The presentation today will primarily focus on manufacturing processes, specifically dry electrode manufacturing. Starting with a company overview, Saueressig is a division of Matthews International Corporation, headquartered in Pittsburgh, Pennsylvania. Saueressig designs and fabricates tooling and purpose-built production lines for industries using high-speed, continuous rotary production. We're a supplier to the clean energy market, both for lithium-ion battery production and hydrogen fuel cell manufacturing. For batteries, we design, engineer, and build electrode calendaring lines, both for traditional wet process and for dry process. This includes lab, pilot, and mass production lines. For hydrogen fuel cell production, we design and fabricate rotary embossing and cutting tools, and have the capability to engineer and build production lines for fuel cell component manufacturing and stack assembly. We have designed and built machines specifically for the production of electrodes using a dry process with no organic solvents. These machines have demonstrated the ability to produce quality electrodes using a dry process. It works by using calendaring systems to produce a web from dry electrode powder, which is then laminated onto a metallic foil. And please note that Saueressig does not manufacture batteries or electrodes. What we do is engineer and build the production lines to enable battery manufacturing. We're supporting the domestic production of batteries in a number of ways. Our electrode calendaring and laminating machines are designed in Germany, but we assemble, install, and commission them domestically. We're building roller refurbishing operation to recoat and refinish the rollers that are worn after use on the production line, which helps extend the life of the rollers. We're also investing in a new application development center in the US for battery manufacturers to experiment with formulations and processes on lab and pilot machines, both for the wet and dry process for electrode manufacturing. To boost domestic capability, we have several workforce requirements, including engineers and skilled labor across multiple disciplines. This includes mechanical, electrical, and controls engineers, electrical and mechanical technicians, as well as skilled machinists. Thank you for the time and for the opportunity to share how we're boosting domestic production of batteries.
Hello, my name is Steve Weiss, president of Xilectric. Xilectric is interested in the demonstration of advanced cell formation techniques that include integrated cell grading. Xilectric is located in Fall River, Massachusetts, in a hub zone. Factory automation and quality control are becoming more and more important. Xilectric's innovative test hardware and advanced formation techniques help address known problems facing the EV market today. First, EVs remain expensive. Costs can be reduced by reducing material input or increasing energy density. However, innovative manufacturing technologies has been deemed the most obvious path to continued cost reduction. Second, commercializing batteries is difficult. Cell development is slow, and cell and pack validation also take many years. Finally, there is a high industry-wide recall rate, which is indicative of the challenges commercializing EV packs using the development processes that exist today. New detection modalities to ensure pack safety and active feedback control for lithium-ion and pack manufacturing is required. Xilectric's core technology is a new electrochemical technique called cyclic coulometry. Cyclic coulometry was invented to measure the loss rate or self-discharge rate of a lithium-ion battery at an addressable condition, for example, at a particular temperature, voltage, or current. At the same time, without any added cost or complexity, the technique measures the associated growth in the complex impedance. Xilectric is currently developing derivative QC metrics based on this and other key insights that can be measured in under 60 seconds. Based on these innovations, Xilectric is developing techniques for cell development, cell modeling, pack and cell validation, as well as manufacturing. Xilectric has been developing fast formation techniques based on our unique hardware for the last year and a half. The goal is to show that cell grading can occur at the same time during formation while providing superior insights to the QC metrics used today, such as multi-week OCV holds. Xilectric is interested in leading a response to Topic Area 12, new manufacturing processes, or partnering for Topic Area 12 or 6 with appropriate partners who are interested in the new formation techniques. The objectives include faster throughput, improved battery insights, and integrated active feedback systems for smart manufacturing initiatives. The program would develop the hardware, process, and algorithms. Xilectric seeks manufacturing partners for lithium-ion or beyond lithium-ion categories. In particular, emerging chemistries may not require the same formation processes, but would still require innovative and advanced cell grading. If you would like to partner with us or have us partner with your project, please email me at the address below. Thank you very much.
We'd like to introduce you to a new manufacturing platform for injection molded batteries, ultracapacitors, and fuel cell plates. Probably best suited for packs. It's an established manufacturing technology that always delivers products faster and cheaper, and in many cases much better. This is an opportunity for which we have IP, issued and pending, trade secrets, and new injection moldable resin compounds. These products can be molded as individual cells, a cell phone battery, in large multi-cavity, multi-shot molds, or as battery or capacitor packs of say 1,000 cells all at once for EVs. Additionally, the wiring bus can be molded in series or parallel as an integral part with the electrodes, thereby further reducing the labor content. The assembly labor costs are gone. Because they are polymer alloys, they are injected under several thousand psi pressure with heat, fusing and surface blending the entire polymer alloy matrix, making it into one solid mass. The anode, the cathode, the electrolyte, the case are all in one solid molded piece. Separation is inherently less probable. There are no air bubbles, gaps, voids, even under hard field use. Additionally, because of this novel manufacturing approach, new conformal geometric shapes are possible. Like all plastic parts, they can look like just about anything you can imagine. Not just the round cylinders or flat rectangles so common today. It is adaptable to many different chemistries, anything that can take the heat beyond lithium. This is a game changer in terms of cost reductions, taking capital and labor out. Physically more robust electrical storage units, probably higher capacities, new product designs, new applications, and geometric options. If this intrigues you, please connect with us on LinkedIn. And thank you for your time and consideration.
The goal of LiBridge is to bring together all battery industry participants to promote a secure, sustainable battery supply chain and establish American leadership globally. We firmly believe that the best way to accomplish that is through a comprehensive set of open industry standards. The benefit of such standardization are briefly introduced in this slide. The first benefit is to democratize market access to battery suppliers and users, giving each participant in the market appropriate real-time access to the market based on their individual functions and needs within the supply chain. Multiple solution providers for each function of the market ensures flexibility while focusing on each contributor's core competencies and value to the market. Efficiencies in managing the supply chain and distribution of a finite resource is of course critically important in a successful supply chain, as is the ability to rapidly introduce innovations and allow the quick adoption of new technologies as they are developed. The successful supply chain will also include trusted certification of activity, transactions, and assets within the market, and will also allow transparent regulatory oversight and reporting. In order to be successful, an open standard has to be applicable today, in addition to providing a clear path for the future. The standards have to be comprehensive and take into account the entire ecosystem over the full life cycle of batteries, from cell manufacture to primary and secondary life deployments through efficient recycling and end of life. The key requirements of a successful open standard for vehicle batteries begins with being agnostic to cell type and chemistry, allowing optimal granularity for vehicle design freedom, flexibility of use, and captured value. The ability to size vehicle batteries for actual use cases on demand is key, as is the decoupling of vehicle production from the battery supply chain. Full tracking of the battery life cycle, as well as certification for compatibility and compliance to the standard, as is ensuring chain of custody tracking and use control. Based on decades of experience, including designing and building high-performance vehicles from the ground up, Modbat has developed a comprehensive suite of technologies. We are proposing them as the foundation for an open, royalty-free industry standard. We call this standard the Extendable Battery Framework, or EBF. It includes Charge Node, a self-contained intelligent module with internal BMS and isolation, Charge Mesh, a resilient, on-demand configurable power system architecture, as well as secure device-linked digital twin NFTs. Though based on proprietary IP, the Extendable Battery Framework is royalty-free to manufacturers of certified batteries and vehicles and administered by the Safe Battery Alliance, a 501c6 nonprofit.
To build the battery-powered economy of tomorrow, U.S. manufacturers today must navigate a complex supply chain, meet safety standards and regulations, and get to market quickly. UL is the global safety science company. We are a leader in testing, inspection, and certification for large batteries and energy storage systems. We have extensive experience serving the entire battery industry value chain through our vast regulatory knowledge and regional laboratories. Since its founding in Chicago, UL has remained steadfast in pursuing safety on the cutting edge of American innovation. Our expertise has helped develop more than 1,600 standards, including the world's first stationary battery, the first energy storage system, and before the market demanded it, the standard for repurposed batteries, anticipating what eventually became a vital piece of the modern supply chain. We also helped develop the recently published UL 9540A test method. We have more than 500 renewable energy experts with deep knowledge of requirements in more than 150 countries. Of the Fortune 500 and Global 500, more than 60% are our customers. And the U.S. National Renewable Energy Laboratory chose us to be the permanent host for SolarApp. Testing is critical to the entire battery supply chain, from manufacturers who rely on our insights into standards and our third-party impartial testing and certification, especially during component process, cell, and pack manufacturing, to government agencies who rely on our expertise to help develop standards, to consumers who rely on the trust and confidence that comes from third-party testing, inspection, and certification. UL is already planning to build the largest commercial battery laboratory in North America. Our funding will build a laboratory capable of battery testing for passenger and light to medium-duty trucks, industrial trucks like forklifts, and stationary batteries for applications such as energy storage, data centers, and telecommunications. However, this laboratory is not designed for the much bigger batteries that power heavy-duty trucks, construction and agricultural equipment, ships such as tugs and ferries, and defense vehicles. With matching grant funds, we can scale up our operation to accommodate these very large battery applications, provide the critical testing that is missing in the marketplace, and add long-term performance testing. U.S. battery independence is critical to maintaining the cutting edge of American innovation, construction, agriculture, shipping, defense. With support from UL, these critical American industries and more can power the country with greater speed, with greater safety, and with greater efficiency through the 21st century.
Where the U.S. has always led is in innovation and in entrepreneurship in breakthrough, frankly, in high technology manufacturing.
What we do is we try to translate our knowledge to the customer, and that comes in the form of projects, that comes in the form of education and outreach.
Running short courses and educational series to make sure that students are getting appropriate training in the energy storage industry.
Everyone's kind of scared of the industry. You can't really go to school for batteries. You don't need the technology specifically in batteries as far as training and schooling to flourish in this industry.
While we won't probably be the quantity leader, we can come in as the quality and the innovation leader.
The vehicle to grid system that I'm standing in front of here with the fast chargers, technology has already been proven that this works. It's not only a charging station, but it's also what they call a bidirectional system that allows a push-pull on the V2G network.
This is where the next technology is coming from. Here's how that technology comes about. Here's what it takes to put it together, and then deploying that throughout the rest of the world.
We really need to mobilize all backgrounds in the industry, and it's going to take all types, from engineers, technicians, communication people, economists, anyone. So even if you don't have a 4-year degree, I encourage people to come to the VIC, come to the industry, learn a lot, join us.
We have a responsibility as an industry to make sure that we're looking at the entire ecosystem. So where does everything come from? Where does it go after you process your part, and what industries does it serve? What product does it go into? And then how we look at extending the life of that product.
Simply put, be a scientist, save the world. So we know that energy has been the #1 problem facing humanity in this century. We need to continue in this vision and advocate for cheap, clean energy.
Challenges and next generation is always a good question here at the VIC.
We have an obligation to advance awareness of second life applications of batteries.
In this industry, a lot of the batteries that are done are not done. There are opportunities to remanufacture, to repurpose into low-cost opportunities or next opportunities, and then there is the recycling.
Find a second home for those batteries, whether it be in an energy storage system, whether it be for home or personal use with the proper training.
And I think through LiBridge, this is an opportunity for us to look at how is what we're doing for others, how can we replicate that model throughout the US? How can we work with others to replicate similar models or assistive models for the balance of the globe as well, but with that focus on the US to get out in front of our manufacturing, our innovation, and our entrepreneurship curve for everyone else.
Battery Streak is an advanced battery materials startup offering ultra-fast charging at room temperature and longer cycle life. With our technology, a cell phone and an electric vehicle could charge to 80% in 10 minutes. You can think of electrodes made with our technology as sponges with very small pores, many times smaller than a human hair. These sponges have a very large surface area per unit of volume. We store energy as a surface charge rather than a chemical phase change. Using these sponge-like mesoporous materials, we charge like a capacitor and discharge like a battery, with minimal heat generation in both processes. Our materials are different, but the battery architecture is the same as any traditional lithium-ion battery, so our batteries can be made on industry-standard battery lines and equipment. Battery Streak is currently moving into a larger facility and increasing our material production by a factor of 20, moving from the prototype to the early manufacturing stage. Battery Streak will be providing a demonstration at the Advanced Naval Technology Exercise Coastal Trident 22. And are currently working with the Army and partners on an aqueous electrolyte. We've also received an NSF, SBIR, STTR grant to develop a cobalt-free cathode. Additionally, other downstream commercial end users have expressed substantial interest. There is a weak link in the U.S. supply chain for bringing new battery technology to market, and that is cell manufacturing. We can get 10, 20, or even 50 cells made by a contractor. But if we need to produce hundreds or thousands of cells per month, there are simply no domestic options. Supporting our growth will allow us to hire more chemical engineers, process engineers, and battery cell manufacturing employees, creating high-level American jobs in the energy sector. It will also allow us to create or develop a partnership with a domestic cell manufacturing facility. Battery Streak respectfully asks that you provide grant support to our advanced battery material development and to increase cell manufacturing domestically, allowing the U.S. battery market to outcompete our international competitors. In addition to direct grants, we suggest considering development zones, tax incentives, and assistance streamlining both state and federal permitting and environmental requirements. Please help us be a part of the LiBridge to continue our advanced materials research and development, create new STEM jobs, and develop domestic manufacturing capacity to serve the DoD and commercial downstream markets. Thank you.
Hello everyone, my name is Jim Myung Lim from Han Energy Enterprises. I'll talk about our plan for demonstration of continuous supercritical hydrothermal ALD-coated single crystal NMC and LFP cathode material manufacturing in the United States. Han Energy is one of the largest private energy companies. We have a long history of operation and development in oil, gas, LNG, refining, power, utility, and energy storages. Our venture is Han Energy Enterprises, and we have been developing ALD-coated single crystal NMC and LFP cathode materials. We have two technological pillars. One is continuous supercritical hydrothermal cathode synthesis, and also the coating solutions by using atomic layer deposition. Our technological status and target in 2022 is scale up. So regarding the cathode material synthesis, our target is more than 2 to 3 tons per year scale up. That is our plan with Argonne National Lab under the United States Department of Energy Battery Manufacturing Program. And then our coating scale up target is more than 10 ton per year level. This is our plan for demonstration. This is 4-year demonstration and development plan. The first year and a half from 2023, our plan is to do pilot scale prove out more than 100 ton per year scale. And also we are going to combine our cathode synthesis and ALD coating into one system. And for the other 2.5 years, we are going to perform the demonstration plant development in the United States. That is more than 1,000 ton per year scale. The picture in the middle is an exemplary picture of demo plant. And the picture on right hand side is one of our existing refining facility. We are going to utilize our existing infrastructure and experience and knowledge and workforce and experts for developing the demonstration plant. These are the challenges of the United States battery manufacturing, and then our approaches and strategies to resolve these issues. Thank you for listening. If you have any questions, please feel free to contact at this contact information to me. Thank you very much.
Dynami Battery Corp enables faster charging and higher power lithium batteries using novel manufacturing technology. Current battery manufacturing technology is robust but lacks precision and flexibility. We create microstructure electrodes using digitally controlled tools. Our proprietary technology leverages self-assembly and self-segregation to place binding materials out of the way of the lithium-ion pads. These microstructure electrodes contain scientifically proven secondary pore networks that enhance the lithium-ion mass transport, creating an electrode that is up to 80% faster charging and higher power. The TRL5 honeycomb-shaped microstructure electrode is compatible with most current and future battery chemistries and architectures, including solid-state cells. Our digital technology allows for faster laboratory-to-factory transition and creates a drop-in solution to current production lines. To fulfill the promise of the electric vehicle industry and enable high-performance aerospace application, innovation in chemistry is not enough. Dynami is developing microstructure electrodes manufacturing technology for better battery cells today. Dynami Battery Corp is growing, and we are looking for financial and commercial partners as well as team members. Dynami is establishing a facility in Maryland where we will expand our technical team in the next 18 months. Help us build a new era of American battery manufacturing. Reach out at info@dynami-battery.com for more information.
At Ateios Systems, we're developing radiation-curable composites to enable rapid, inexpensive, and cleaner electrode manufacturing, thus addressing battery manufacturing here in the US. We've identified that the manufacturing process of the key components, specifically electrode, has remained unchanged since the 1980s. This is bottlenecking efforts to scale and lower costs. We find that the current process is extremely slow, expensive, and toxic, where we take these toxic solvents, mix them with battery powers to make kind of a ink that is then coated onto metal foils to form an electrode. This solvent is removed with expensive, long thermal runners and becomes extremely toxic and has to use an expensive process and energy to remove these solvents. And so that's why here at Ateios, we've developed a new solution that uses light. We have proven the elimination of these solvents and this process will enable electrode manufacturing to be 10 times faster, 5 times cheaper, and in fact 12 times cleaner, without compromising performance. And what's really exciting about this technology is that it is chemistry agnostic, enabling its use on any type and size of battery. From developing better batteries for wearables and IoT in a $300 million market, scaling to drones and power tools, and eventually impacting the $50 billion market for grid and mobility. And while we and our company need significant support in developing this technology, we know that the US has to make significant infrastructure and workforce advancements to allow the whole industry to pursue forward. And we see that the US faces many challenges across this whole spectrum of the value chain, from material, electrode manufacturing, and battery assembly, because only 1% of lithium-ion batteries are manufactured domestically here in the US. And we can look to the past for a solution, where in the 1980s, the US faced the same challenges in the semiconductor industry that we face today. It made significant investments in called Semitech that dedicated the investment in building the infrastructure, education for workforce, and advanced materials to keep America ahead across the competition. And we believe in this model because we've already proven it here at the Battery Innovation Center. This is one of 3 facilities in the US, significantly smaller than Semitech, but has allowed our company and a lot of others to move faster, understand their costs, and build robust teams. And we believe this is the model, along with our technology, to really enable battery manufacturing here in the US. Thank you.
EaglePicher Technologies, a superpower in battery technology. EaglePicher is uniquely qualified to provide power. We can connect technology to manufacturing. We understand the full spectrum. We start with chemistries, develop cells, build batteries, and have American manufacturing. With 100 years of battery history, we tackle mission-critical power challenges. EaglePicher supports industries with mission-critical applications. We are a leading supplier of missile batteries. We hold approximately 85% of the U.S. market. As the leading provider of thermal battery systems to the Department of Defense, EaglePicher supplies power for the majority of the U.S. military's missile and precision-guided munition systems. EaglePicher became a battery supplier to the U.S. government in the 1940s when we supplied our first battery for a military Navy application. Our products are used in defense systems such as missiles, torpedoes, and advanced programs, including directed energy weapons, hypersonic systems, and unmanned underwater vehicles. Whatever the requirement, EaglePicher has the solution to power your military application. EaglePicher's space heritage dates to the earliest days of the U.S. space program, when we powered the first U.S. satellite. EaglePicher has supplied batteries for more space missions than any other company. Our space batteries have powered launch vehicles, satellites, space research missions, and manned and unmanned missions. EaglePicher developed and manufactured the first lithium-ion battery ever used in military aviation for the B-2 bomber. Whether it is 2 batteries for a Mars rover or 2 million cells for aviation, EaglePicher will always rise to meet the individual demands of our customers. EaglePicher has a long history of battery development for the medical industry. We developed and manufactured the first human implantable lithium-ion battery and the world's smallest implanted battery. The EaglePicher team is based solely in North America and focuses on the development and manufacturing of power solutions. EaglePicher's domestic manufacturing footprint provides us the ability to conduct rapid prototyping. We have advanced automation manufacturing facilities and scalable automated production lines. Thank you for joining us. For more information, visit www.eaglepitcher.com.
Hi, my name is Eric Roundtree. I'm the head of operations and business development at EC Power. We are the inventors of the thermally modulated lithium-ion cell. This technology was key for the all-climate battery, which was recently featured at scale, powering the public transit system for the 2022 Winter Olympics. It has also been utilized in the development of the Fastline Extreme Fast Charging Battery Series, and is now paving the way for true economy electric vehicle batteries that are safe, affordable, and critically practical, from top to bottom, for the end user, the manufacturer, and the battery designer. Currently, our technology, which is 100% American-owned, is only produced at the prototyping scale within U.S. borders. In the past, we relied on foreign partnerships to achieve our automotive demonstrations and Olympics deployment. Now the opportunity is here to change this. We are well positioned to provide a distinct competitive advantage for the U.S. battery ecosystem. The DOE's planned $7 billion investment can significantly shorten the time required to bring this to fruition. EC Power and our partners will build a production line that produces our proprietary cells and plug-and-play modules under the same roof. The facility will supply modules to targeted traction battery markets already undergoing electrification, and will be a demonstration line to help automotive partners build out new or retool existing battery lines for our technology. In tackling this vision, we realized that we were part of a greater battery manufacturing infrastructure. To be cost competitive at the cell module level, we must be able to domestically acquire the raw materials at cost competitive prices. We must have recycling efforts built out near our plant facilities to drive down the cost and waste of scrap cells. Beyond materials, we must invest in our communities. The skills needed to build out efficient manufacturing lines are already present. Education is required to sharpen those skills around the unique challenges of lithium-ion battery production. In the short term, the few advanced battery companies that exist in the U.S. will need to bear a significant amount of the burden for that training, and will need support in this effort as we scale. In the long term, facilities akin to small, advanced toll manufacturing centers should be built out at numerous universities across the country that can provide training, students, and opportunities for low-cost innovation to the many new startups that we should expect to see in this space. For small businesses, the heart of our country's ingenuity, these manufacturing centers eliminate the capital needs associated with building out full pilot lines, instead allowing them to focus their full attention on their specific area of innovation within the supply chain. With proper allocation of proposed investment by the DOE, the U.S. can do more than just participate in the global battery revolution. We can lead it. The technology needed, ours and others, is already here. It's imperative that it stays here and that it scales here. EC Power is looking forward to playing our role in that future.
Hello, this is Chris Abram from Nano. We're a small business based in New Jersey, and we want to share with you our battery cathode manufacturing technologies with a view to developing fruitful partnerships to scale up these technologies in the United States. So we began in Princeton University in 2017, and our mission is to develop environmentally friendly manufacturing solutions for high performance energy storage materials for electric vehicles. So we've 3 relevant patents on the technologies I'll be talking about. We receive funding from the Department of Energy and actively collaborate with academic and industry partners in the materials, batteries and electric vehicles area. So we are providing solutions for the next generation of cathode manufacturing. So the co-precipitation route is the prevailing cathode production technology, and it's dominated by countries such as China, Korea and Japan at present. So in this process, metals are processed into metal salts, which is itself an energy-intensive process. Sulfate salts are then fed into the co-precipitation reactor, which requires additional chemicals and generates wastewater, which requires energy-intensive processing for recovery. So in other words, this is a time-consuming, capital-intensive and environmentally damaging process that needs to be updated. We have two technologies which are completely different. First, we're working on an aerosol synthesis process. It forms a lithiated active cathode material with low energy and no additional chemicals in a rapid process step. Second, we're working on a direct metal oxidation to cathode process. This process completely eliminates the conversion of metal to metal salts, which further reduces the time, the environmental impact, and the cost of the cathode material significantly. Turning to the first of these technologies, the aerosol method is very flexible for designing novel materials with precise ion doping. So as shown, we can achieve selective ion precipitation, which forms a concentration gradient structure. This improves the thermal stability and the electrochemical performance of the material. Moreover, this method has a very broad compositional flexibility, is fast, and it requires no additional chemicals. In the second method we're working on, direct metal oxidation to cathode. From a manufacturing standpoint, this method is truly single step. It completely eliminates two major steps in co-precipitation by working directly with metals, and it's fully compatible with existing plants, so it makes scale up very straightforward. So we can use this method to produce gradient structure, high performance cobalt-free and nickel-rich materials. In summary, these are two technologies which have the potential to transform conventional cathode manufacturing, and we are looking for partnerships to commercialize these technologies and establish environmentally cathode manufacturing here in the United States. Thank you.